Imagine creating a super reliable watchdog for your home network that costs just $5 and fits in your pocket. It's not science fiction, it's my latest DIY triumph with an ESP32 microcontroller. If you're into self-hosting, you've probably heard of Uptime Kuma, that awesome open-source tool for keeping tabs on your servers and apps. Check out this guide. https://www.xda-developers.com/uptime-kuma-guide. It's great for tracking if everything's running smoothly. But what if I told you that you could skip the full software setup and build a custom monitor right on a tiny, low-power board like the ESP32? For beginners, the ESP32 is basically a small computer chip with built-in Wi-Fi. Think of it as a smartphone brain without the screen or battery drain. It sips power like a miser, yet it's got enough muscle to send out web requests, ping devices to see if they're alive, and even run a mini website to display the results. As a fun experiment, I transformed my ESP32S3 model into a dedicated uptime checker, and let me tell you, it performs way better than I ever expected. This whole adventure kicked off with a whimsical thought: could I really mimic something as polished as Uptime Kuma on such a basic piece of hardware? What began as a light-hearted tinkering session evolved into one of my top home lab toys. It's incredibly energy efficient, starts up in mere seconds, and stores all your monitoring setups in a compact file system called LittleFS right on the device itself. For newbies, LittleFS is like a tiny hard drive built into the chip, perfect for saving configs without needing extra storage. On top of that, it serves up a clean web interface where you can glance at the status of your Home Assistant setup, your Jellyfin media server, or whatever else you've got running. Simple? Yes. Speedy? Absolutely. And reliable enough to trust with your daily checks? Surprisingly so. But here's where it gets really intriguing, and maybe a bit controversial. Why settle for software that could crash alongside your servers when you can have a standalone hardware sentinel? Traditional monitoring tools often live on the same machines they're supposed to watch, which is like having a lifeguard who drowns in the same wave. This ESP32 version changes the game by being a physical, unchangeable device plopped right into your network. Picture this: your Proxmox cluster, a virtualization platform for running multiple virtual machines on one box, bites the dust, your Home Assistant smart home hub glitches out, or your NAS storage drive freezes up. Most monitors would go dark too, but not this little guy. It's always on, independent, and ready to alert you because it's not tethered to the failing hardware. As a compact, focused gadget, it slots perfectly into your self-hosted ecosystem, and you can even tweak it to grow with your needs. So, why go the DIY route for an Uptime monitor? Let's break it down. It operates independently from your main setup. You've got options galore for service checks, Uptime Kuma, fancy dashboards with Grafana and Loki. Here's how to set one up in your home lab. https://www.xda-developers.com/set-up-grafana-loki-prometheus-alloy-home-lab. Prometheus for metrics collection, old-school Nagios alerts, and tons more. But here's the catch most folks overlook. They all demand beefier hardware than a simple microcontroller and rely on your overall system staying healthy. If the host machine tanks, poof, your monitoring vanishes. And that defeats the whole purpose of watching for downtime, right? Sure, you can have isolated virtual containers or machines crash while the host hums along, but when the entire host fails, everything on it, including your watchdog, goes offline. Enter the ESP32, it elegantly sidesteps this flaw. This standalone board is laser-focused on monitoring duties, untied from servers, Docker containers, Proxmox environments, or any VMs. Just flash it with your Wi-Fi details, and it's good to go, affordable at around $5, with Wi-Fi smarts and just enough processing power for essential checks. It's isolated, so if your home lab suffers a total meltdown, the ESP32 keeps chugging, pinging away and hosting a basic status page to reveal the chaos. To be upfront, another driver for this build was sheer curiosity. I was eager to test the limits of a microcontroller as a legit network tool. With tricks like async web handling, which lets it multitask without freezing, little fs for storage, JSON for data wrangling, and a simple web front end, the possibilities stack up fast. Having tinkered with ESP32 projects before, like building custom sensors or IoT gadgets, I figured it'd hold its own, but I was blown away by its seamless performance. The real-world applications jumped out immediately, especially for anyone wanting a cheap, dedicated monitor without overkill. Diving into how my ESP32 Uptime monitor ticks. You set up a service, and it regularly probes it for status. When it powers on, the ESP32 links to your Wi-Fi, loads its little FS storage, pulls in your saved services from a JSON file. JSON is just a lightweight way to structure data, like a simple spreadsheet in code, and fires up an async web server for easy access. All tweaks happen via the web interface, no need to reprogram the chip just to add a new service. After the initial setup with your network credentials, you might never touch the code again unless you're innovating with new features. Each service you monitor is outlined with basics like a friendly name for it, the type, e.g., Home Assistant, Jellyfin, a general webget, or a ping test, the target host or IP address, the port number, an optional path for HTTP checks, like hitting a specific URL, an optional snippet to look for in the response, to confirm it's not just alive, but healthy. How often to check, in seconds. The device scans its list every 5 seconds, figuring out which services need a fresh look based on their intervals. This smart setup lets you hound critical services often while giving less vital ones a breather. Say, check your security cam every minute but your media server every 5. When something flakes out, the dashboard refreshes instantly to flag it. Service types are built to grow with you. You can customize actions per type and auto-suggest ports for convenience. For example, Jellyfin uses its /health endpoint to verify it's okay, while Home Assistant just needs any response to signal it's responsive. And this is the part most people miss. These checks can be as basic or thorough as you want, making it beginner-friendly yet powerful. Breaking down the types. Home Assistant sends a request to the API path. Any HTTP response, even a 404 error, means it's up and running. We could beef this up to verify a real endpoint like /API/states for deeper insights, but the quick 404 check keeps things snappy and confirms basic connectivity. Jellyfin hits the /health URL and waits for a clean 200 OK status code, proving the server's healthy. Get request grabs the designated path and scans the reply for your specified text, great for custom sites, like ensuring your blog's homepage says welcome. Ping fires off ICMP echoes, that's the technical term for those are you there, pings, using a library called ESP32 ping, then listens for replies to confirm reachability. Results live in the device's memory and get served via a JSON endpoint. The web page pulls this every few seconds, refreshing the view with the newest data. We also log the check time, any errors, and status shifts for a dynamic snapshot. It's like having a live feed of your network's pulse, spotlighting what's solid and what's sputtering, perfect for spotting issues before they snowball. I can't get enough of this creation. And it barely touches power. The magic here isn't about outshining Uptime Kuma in every way, it won't, and that's not the goal. Its appeal lies in the elegant simplicity, core HTTP and ping probes, straightforward validations, all wrapped in a setup that draws negligible electricity, runs whisper quiet, and shrugs off server crashes since it's an outsider looking in. I designed it for easy expansion. With modular functions and distinct service handlers, you could layer on MQTT for messaging, a protocol for efficient device chatter, or notifications via Telegram or Discord. Imagine pings to your phone when downtime hits, without depending on your flaky home setup, just needing internet, naturally. But let's stir the pot a bit. Is a $5 hobby project really robust enough to bet your self-hosted empire on? Or is it just a fun toy that glosses over the reliability of pro tools? Some might argue full software like Uptime Kuma offers more features and integrations, but I